Welcome, everyone, to TechDaily.ai. This deep dive is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup disaster recovery, hyper-converged VMware, Hyper-V, Proxmox cluster AI servers, SA365, a turnkey security appliance, public and private cloud. Check out stonefly.com for more info. Today, we're diving headfirst into the world of enterprise networking, specifically Cisco's brand new C9000 smart switches.
Yeah, these aren't just, minor tweaks.
Exactly. They seem designed from the ground up to tackle some really intense and rapidly evolving demands on our networks. So, our mission today, let's pull back the curtain, understand exactly what these new switches bring to the table, and critically, how they relate to some of the, real-world experiences and discussions we've heard from network admins in the field about their predecessors. So let's unpack this. We're in this period of, unprecedented tech acceleration. You think about the explosion of AI workloads.
Oh, definitely.
And the very real deployment of Wi-Fi 7, and even that looming shadow of quantum computing. How are these huge shifts fundamentally changing what we demand from our networks?
Yeah.
And why are we seeing such an urgent push for entirely new hardware rather than just, incremental upgrades?
Well, what's truly fascinating here is how these technologies aren't just adding traffic volume, they're radically altering its nature. Take AI workloads, for instance.
Okay.
They demand incredibly low latency, immense capacity, and, importantly, built-in security. It's really unlike anything we've seen before at this scale in the enterprise. We're observing this significant shift in traffic patterns, too.
Yeah.
Traditionally, networks saw more downlink traffic, web browsing, video streaming, that kind of stuff.
Pulling data down.
Exactly. But with AI, there's this surge in uplink traffic. Think training models, real-time inference, interacting with AI agents, and this traffic, it's notoriously bursty and hyper-latency sensitive. I mean, imagine a hospital trying to process AI-driven diagnostics. Even milliseconds of delay can have serious consequences. Your network just cannot afford to be the bottleneck anymore.
Makes sense. And Wi-Fi 7, you mentioned that too.
Yeah, Wi-Fi 7. This isn't just theoretical anymore. It's actually pushing network boundaries far beyond the old 1 gig per second limits in real-life scenarios. Multi-gig connections are fast becoming the new baseline for wireless access.
So the wired backbone have to keep up.
Absolutely. It means the wired infrastructure supporting those access points has to keep pace. Otherwise, you're essentially building this superhighway that immediately bottlenecks into a single-lane road at the on-ramp. It just doesn't work.
Right.
And then looking a bit further down the road, the threat of quantum computing is becoming increasingly relevant, especially for network and security folks.
The harvest now, decrypt later idea?
Precisely. It's kind of chilling, right? Sensitive data stolen today could potentially be effortlessly decrypted by powerful future quantum computers. I actually heard a story about a financial institution that started reassessing their data retention policies specifically because of this. They were thinking, if this highly confidential data is still sitting here in 10 years, could it be cracked?
Wow.
Yeah, it's making network design a much longer-term security play. It's driving this urgent need for post-quantum cryptography, PQC, right into our network designs today. It's about being proactive.
Okay, so these challenges aren't just about more bandwidth. They're entirely new paradigms. Incremental upgrades just aren't going to cut it, it sounds like. So how has Cisco truly reinvented the wheel with these new C9000 smart switches, specifically the C9350 and C9610, to meet these demands?
Right. Well, their core purpose is to power campus networks with immense throughput and incredibly low latency. They're specifically designed to handle these high-stakes AI applications and, the multi-gig needs of Wi-Fi 7. And a really critical point is that they are powered by Cisco Silicon One. That's their custom-built chip designed specifically for network processing.
Like an ASIC.
Exactly, an application-specific integrated circuit. Think of it as a super specialized engine, finely tuned for moving data at lightning speed, way more efficiently than a general-purpose processor could. And importantly, they bring quantum-resistant secure networking directly into the hardware, addressing that harvest now, decrypt later threat head-on.
Okay, and the specific models, C9350 and C9610.
Yeah, so the C9350 is positioned as the next-gen stackable switch. It's perfect for building out those agile, scalable access layers. The C9610, on the other hand, is a modular chassis. It's much like the previous high-end Catalyst models you might be familiar with, but built for much larger scale core or aggregation layer deployments.
Okay, here's where it gets really interesting, getting into the nitty-gritty. Let's peel back the layers. What exactly makes them smart beyond just handling more traffic? Let's start with the C9350.
Okay, sure. The C9350 is built around the powerful Cisco Silicon One A100 ASIC. This network processing unit is capable of 1.3 terabits per second.
That's a lot.
It is. And what's crucial for performance in demanding environments is its stacking. It boasts an impressive 1.6 terabits per second of stacking bandwidth. And importantly, its front panel ports are non-oversubscribed.
Non-oversubscribed. What does that mean in practice?
It's a key architectural difference. It means that unlike some switches where the total internal bandwidth is kind of shared across ports, here every single port can run at its full advertised speed simultaneously. No hidden bottlenecks.
Ah, okay. So for those high-demand AI servers or the new Wi-Fi 7 APs.
Exactly. They're guaranteed to get the full pipe they need. It eliminates those hidden performance ceilings that can be really frustrating to troubleshoot.
Gotcha. What about scale?
In terms of scalability, you're looking at a significant leap, like 4 to 6 times higher in terms of access control lists, ACLs, and routing tables compared to the existing 9300 models.
Wow, 4 to 6 times.
Yeah, it's huge for complex networks with really granular security policies or intricate routing needs. And there's also a major architectural shift in how stacking works. They've moved to a standard Ethernet-based VXLAN protocol for stacking.
VXLAN for stacking, that's interesting.
It is. It allows for much more flexible physical connections beyond just the traditional ring topology. Imagine you have racks spread across a data center, not just neatly lined up. This new architecture also significantly improves resilience. If a stacking cable fails, it only affects a portion of the bandwidth, not the entire stack going down. It gives you much better fault tolerance.
Okay, that makes sense. And power over Ethernet, critical for access points and other devices.
Right. So the C9350 confirms full compliance with 802.3 BT. That's the standard for 60 watt or 90 watt per port PoE.
So it can power those beefy Wi-Fi 7 APs?
Definitely. Or high-power cameras, thin clients, you name it. Cisco's UPoE and UPoE Plus terms you might hear are basically just their marketing terms for these standard options. But it's really vital to emphasize, you need sufficient power supplies in the switch itself to meet the aggregate power budget demands if you're running lots of high-powered devices.
Good point. Don't skimp on the power supplies.
Exactly. And for physical high availability, it features N+1 fan redundancy. It has 3 fan modules, and this new 3-power supply modular design that supports both combined power and N+1 or even N+N redundancy.
So redundancy on top of redundancy.
Pretty much. It means your network stays up even if components fail, minimizing that critical downtime.
Okay, that's a remarkable level of power and flexibility packed into the C9350, especially for that access layer. But for the truly large-scale, enterprise core or aggregation deployments, you need something even more substantial. So how about the C9610? How does that scale up?
Right, the C9610 takes it a significant step further. It uses a centralized architecture. It's a 10-slot chassis, 2 supervisor slots for redundancy, and 8 line card slots.
10 slots, okay.
Yeah, and this behemoth boasts a total chassis capability of 51.2 terabits per second, with an impressive 6.4 terabits per second per slot.
51.2 terabits.
Yeah, that's enough raw bandwidth to handle, well, pretty much the most demanding core network applications you can throw at it. And you have 2 supervisor options. There's the SUP3 based on the E100 ASIC, and then the SUP3 XL, which uses the more powerful K100 ASIC.
What's the difference there? Just speed.
Well, interestingly, both deliver the same raw performance, but the XL offers higher scale and buffer capacity. That's crucial if you're managing enormous routing tables or need to handle immense burst traffic without dropping packets. And they've designed it with investment protection in mind, too. Existing 606 line cards can actually be used with an adapter.
Oh, that's good news for budgets.
Yeah, it helps organizations transition without having to immediately replace all their previous investments. And a practical point, but often overlooked, the design. It has a front-to-back airflow, which is standard now, but also this industrial-first centralized cable backplane.
What does that actually do?
It's not just marketing speak. It's a thoughtful engineering choice. It allows for natural air circulation so it dissipates heat really efficiently, and it helps maintain high-speed signal integrity across that vast internal bandwidth. Helps with reliability over time.
Okay, so these switches are clearly built on some serious tech underneath. Silicon One chips, the next-gen iOS X operating system. What's the secret sauce in those components that makes them so capable and secure? It can't just be about faster forwarding, right?
You're absolutely right. It's much more about intelligent processing and foundational security. Take the Cisco Silicon One, like the K100 ASIC and the C9610 supervisor. It's a 7-nanometer chip, impressive bandwidth, around 9.6 terabits per second, multiple packet processing slices. It's not just fast, it's designed for smart, efficient data handling.
Okay. And the buffering. You mentioned bigger buffers on the XL supervisor.
Yeah, the buffering system is particularly innovative. It uses this dual buffer approach. There's a 64 millibit shared memory subsystem, the SMS. That's designed for your low latency traffic, like video and voice.
The VIT lane?
Kind of, yeah.
Yeah.
Think of the SMS as the express lane for urgent AI requests and real-time voice. But then there's an 8 gigabyte high bandwidth memory, or HBM. That's for guaranteed delivery and absorbing those large, unpredictable bursts of data, like your flexible, massive storage for extreme peaks.
So how do they work together?
Well, packets first hit the SMS buffers. If more buffer is needed, they kind of spill over to the HBM. But crucially, packets from HBM have to return to the SMS before being sent out. It optimizes the flow. This dual approach means your critical AI workloads get that instant responsiveness and your large data transfers don't choke the network, even during those extreme peaks.
That sounds pretty smart. And the OS Next-Gen iOS XE.
Right. This operating system is designed from the ground up for programmability, virtualization, AI readiness. It incorporates something called microservices process modularity.
Microservices, like in software development.
Exactly like that. Think of it this way. Traditional OECs are often like one single massive program. If one part crashes, sometimes the whole thing goes down.
Yeah, I've been there.
Right. So microservices modularity is like having individual independent apps running inside the switch OS. If your web server process hiccups, maybe the routing process isn't affected and the switch stays up. It means significantly less downtime and allows for easier real-time updates and patching without needing a full system reboot. That's a potential game changer for maintaining network availability.
Okay, less disruptive upgrades. What about management?
For management, there's this unified platform and licensing model. They call it UNX. This gives customers flexibility. You can manage devices via the cloud or on-premise, say, in an air-gapped environment for high security or through hybrid models.
So blurring the lines between Catalyst Center and Meraki.
Pretty much, yeah. It gives you more choice and potentially a more consolidated view of your whole infrastructure.
And security. You mentioned quantum resistance.
Security is really fused directly into the network here.
Yeah.
These switches are quantum safe, PQC compliant at the hardware level with a dedicated chip. So that addresses the harvest now, decrypt later threat we talked about. They also leverage what Cisco calls trustworthy solutions. That includes hardware authenticity via a trust anchor module, which basically verifies the integrity of the hardware itself, making sure it hasn't been tampered with.
Like a hardware root of trust.
Exactly. There's also a feature called Cisco Live Protect, which is supposed to provide compensating controls for faster vulnerability fixes. And of course, you get robust features like AES GCM 256-bit crypto engines for strong encryption, M80sec for securing traffic between devices, IPsec for secure VPN tunnels. It's a multi-layered approach. Security isn't an afterthought, it's foundational.
And finally, high availability, keeping things running.
Oh, absolutely paramount. These switches protect business continuity with stateful switchover, SSO. That offers sub-second failover, they claim less than 5 milliseconds within the chassis, or via the next generation stack-wise virtual between chassis.
So if something fails, the network hardly blinks.
That's the goal. They have redundant hardware components, obviously power supplies, fans, supervisors, and operational resiliency is enhanced through features like SMU software maintenance updates and ISSU in-service software upgrades.
Right, the upgrades without downtime.
Exactly. Applying patches and even upgrading the OS without bringing down the network. That dramatically reduces planned downtime windows. And they support resilient Layer 3 topologies, helping ensure your network stays incredibly stable, even under pressure or during maintenance.
Okay, so on paper, these new smart switches are undeniably impressive. Capabilities, design, they seem built for the future. But this raises a really important question for you, the network administrator, who's actually, in the trenches. How does all this innovation relate to, or maybe address, some of the very public concerns we've seen, like those discussions on Reddit about reliability issues with the existing Catalyst 9300 series? Should admins be worried or maybe reassured?
Yeah, that's a very valid and important question. And it's true, there have been very public concerns from the community. Several users reported, alarming rates of failures with existing C9300s. They cited a whole range of issues, things like complete power over Ethernet capability loss, even when the power supplies themselves were fine. Imagine how frustrating that is to troubleshoot.
Oh, yeah?
There were widespread reports of faulty boot flash leading to repeated RMA requests. The headache of constantly replacing switches just to keep your network operational.
Nightmare fuel for an admin.
Totally. And some describe switches just randomly bricking no lights, becoming totally unrecoverable, sometimes displaying cryptic boot fail W errors.
Yeah.
That kind of unpredictability is exactly what you don't want in your network core or access layer.
So did Cisco acknowledge this?
They did, actually. Cisco acknowledged a potentially faulty batch of C9300s. It was due to a corrupted DIMM, a memory module, impacting specific serial number ranges. They published those ranges, like FJC2437CAXX to FJC2550XXX and FOC2545XXX to FOC2528XXXX.
Okay, so it wasn't just isolated incidents, it was a recognized manufacturing issue.
Correct. It affected a specific cohort of devices, which is important for transparency, at least.
Were there other concerns besides the hardware failures?
Yeah, beyond those specific hardware issues, the community also raised broader concerns. Some perceive certain moves by Cisco as, let's say, cost-cutting measures rather than genuine engineering innovation, which kind of impacted trust. There were also noted stability issues with specific iOS XE software versions, like I think v17.3.5 or 16.6 were mentioned, causing unexpected behavior. And some grumbling about issues related to Merakification, the integration with Meraki cloud management, sometimes leading to unexpected complications or limitations.
Okay, so connecting this back to the new switches.
Right. If we connect this to the bigger picture, the introduction of these new C9000 smart switches and their next-gen iOS XE architecture, well, it appears to be a direct response. It emphasizes a renewed focus on enhanced reliability and an improved underlying design. That push towards microservices modularity we talked about, the advanced HA features like SSO, the unified management, these are clearly intended to create a more stable and resilient platform overall. And the shift to Silicon One. That's also part of Cisco's stated vision of building hardware that is going to serve our customers for the next decade. It suggests a commitment to a more robust foundation going forward. So, arguably, they're trying to directly address those past reliability concerns through both hardware design and software architecture improvements.
This raises a really important question, I think, for all of us building and maintaining networks. As networks become more intelligent, handle these incredibly complex demands like AI, how much of our trust should we place in, say, software-defined reliability and all these advanced features versus the foundational robustness of the hardware itself?
That's a great point. It's a delicate balance.
Yeah, and how do we, as informed professionals, evaluate vendors and brand new product lines when past hardware issues like these surface? Should we see it as a red flag or maybe as a sign of a vendor learning and adapting? It's a critical balance to consider as you build your future-ready network. It really challenges us to dig deeper than just the spec sheet, doesn't it?
Absolutely. You have to look at the track record, the response, and the new architecture.
Well, that wraps up our deep dive into Cisco's new C9000 smart switches. We hope you gained some valuable insights into the innovations driving the next generation of networking and how vendors are responding to some of these real-world challenges. Before we go, just a reminder to check out Stonefly's 100 TB immutable and air-gapped SSO NAS. It's available for just $8,995. You can find more info on their site. Thank you for tuning in to The Deep Dive. Until next time, keep learning.